Good morning, guys. Welcome back. This is week 7, day 1. And today we're going to continue with the topic that we started last week. So last week we started with the formulas for perfect squares. We learned that when we have a parenthesis to the square is the same thing as having the parenthesis multiplied times itself. Like in this case, x plus 2 times x plus 2, since they're exactly the same, it is the same thing as saying x plus 2 to the square. And we got two formulas, one for the addition and one for the subtraction of perfect squares. We got that a to the square plus 2ab plus b squared is the solution for the sum of the perfect square. And when we change this sign to a negative, then that's the only change. We have the solution for the difference of a perfect square. And we did some exercises in here, and we also solve it with FOIL, and we determined that it is exactly the same thing. Okay, so now we're having placed the topics name. Now we're going to continue with the third form of this special scenarios, this specific situations or special cases. Okay, now today's May 10th, 2022, and we're going to see the formula number 3, as you can see, formula number 3, difference of squares. Okay, what's the particularity of a difference of squares? The particularity is that we have the same monomials, but one is an addition and the other one is a subtraction. So they're exactly the same numbers, but one is an addition or one is a subtraction, or it can also be the other way around. One is a subtraction and the other one is the addition. It doesn't matter which parenthesis goes first, okay? And we are not going to use the distributive property or the FOIL method, which we could. We're going to use it in here just to determine that it's the same answer. But we're going to see how to solve it using the formula. As you can see, the formula says A plus B. Okay, that's what it says, a plus b times a minus b, and that will be equal to a squared minus b to the square. So what is the first thing? The first thing we're going to do, just like in the first cases, is to determine what is a and what is b. Okay, how do we determine it? Exactly the same way. From the sign to the left, that's a. From the sign to the right, that will be b. Then we substitute and we simplify. So in this case, it doesn't matter from what parenthesis you pick it because it is exactly the same thing. So this is going to be a, and from the sign to the right, that's going to be b. And remember, we are not taking into account the sign because the sign has already been placed over here. We don't need the sign, okay? So what do? We're going to say instead of a, we are going to use x in the formula, a squared minus b to the square. Okay, so we're going to use x, and that goes to the square, minus, instead of b, we're using this 2, always in between the parentheses, to the square. And we simplify. How much is x to the square? X squared. Minus how much is 2 to the square? 4. So minus 4. And that's it. This is the only case where you multiply a binomial times another binomial and your answer will be a binomial. Usually we get a trinomial, or some cases, depending on the exponent, we might get a 4-term polynomial. But this is the only case where you get a binomial from the multiplications of 2 binomials. And that's the answer using the formula. Easy peasy. So now we're going to prove it using the FOIL method. Okay, we're going to multiply the first term times everything inside the second parenthesis, and the second term of the second parenthesis, the first parenthesis, multiplying everything inside the second one. So x times x, x to the square. X times negative 2, negative 2x. We're finished with the first term. Now we go with the second one. 2 times x, positive 2x. And 2 times negative 2, negative 4. We said that when we have exactly the same exponents in our variables, middle terms are going to be like terms. But as you can see, one is negative 2x and the other one is positive 2x. So when we have exactly the same number, but one negative and one positive, we have that to be 0. So we cancel that out. So we have now x to the square minus 4, okay? So do we get it? No questions, you see? Same answer, different methods. Okay, then. So we're going to continue now doing the rest using only the formula, okay? Only the formula. So let's see. What are we going to do? We're going to have x plus 3 times x minus 3. So in this case, I'm going to identify a and b from the second parenthesis, and you'll see that it will get exactly the same procedure. It doesn't matter. Okay, so this is a, and this is b. Since they're both x and both are 3, but one added and one subtracted, we are able to use this formula that we have over here. So I'm going to copy my formula, and now I'm just going to substitute, okay? So instead of a, x, and that goes to the square, minus, instead of b, 3, and that also goes to the square. And now we just go ahead and simplify. X to the square, x squared, minus 3 to the square, 3 to the square,
9.
9. So you see, this is called the difference of squares because the first number is to the square, the first term is to the square, and the second term is also to the square. You can find a square root, okay? Remember that I've told you that the opposite or the inverse operation of an exponent is a root? Well, this can be solved with the square root. Now, let's go with the third exercise, which, as you can see, we are increasing a little bit the complexity because now our variable has a coefficient. Okay, now it is 2t minus 1 times 2t plus 1. And you see, I told you, it doesn't matter if the addition is in the first parenthesis or it is on the second one because it is a multiplication. So at the end, it doesn't matter, okay? So same thing, we're going to identify A and we're going to identify B. So help me out. What is A? What is A? What is A? What is A from here? Identify A.
2t.
2t. From which parenthesis? It doesn't matter. So I'm going to identify it from here. A. And how much is B? How much is B?
1.
1. From what parenthesis? It doesn't matter. So you can pick it like that because you're exactly the same. So it could be both from the first parenthesis, both from the second, A from the first one, B from the second, and it doesn't matter. At the end, we will have exactly the same answer. So I'm copying my formula and now I'm going to substitute. Always inside a parenthesis, the 2t because that's A and it goes to the square, minus B, which is 1, and it goes to the square. Now, what should I do in this case to simplify? I need to do powers of powers, okay? So that's what I'm going to do. I'm going to solve that with the power of a power. How much is 2 to the square?
4.
4. And how much is t to the square? T squared. minus, how much is 1 to the square?
One.
1. And that's it. We'll finish our exercise like that. Easy peasy, right? So sometimes you can pick it from the first one, sometimes from the second one. That's okay, Jorge. And sometimes you can mix it up. Let's increase a little bit more the complexity of our exercises. We got 3x squared minus 5y cubed times 3x squared plus 5y cubed. So as you can see, now both terms have coefficient and both terms have a variable and both terms have exponents with their variables. Will it change anything? No, it will not. It won't change anything. So let's identify A and B. How much is A?
Is 3x cubed.
3x squared. Very good. I want to identify it from here. It doesn't matter because both first terms of each parenthesis are the same. How much is B?
5y to the third power.
5y to the third power. And I want to identify it from here. Does it matter that I identify it like that? No, because I'm identifying it from the right of the sign, okay? So it will be practically the same. So let's use the formula that we have over here. We always copy the formula so we don't forget what we're doing. And we just go ahead and substitute. So we're going to say 3x to the square. And that goes to the square minus b, which is 5y cubed. And that also goes to the square. What do we do in this case to solve it? What should we do in this case to solve it? How do we solve it? How do we solve it, guys? We solve it with
Power of a power.
very good, power of a power. Now, let's solve that. How much is 3 to the square?
9.
How much is x squared to the square?
X to the 4th.
X to the 4th power, very good, because we multiply the exponents. Minus, how much is 5 to the square?
25.
25. How much is y cubed to the square?
6.
Very good, 6, because 3 times 2, it is 6. So you see, it doesn't matter if our variables have exponents or not. We just do the power of a power, and that would be it. Okay, last exercise, I'm sorry about that. I'm going to move a little bit here so you're able to see the formulas. So you see the formulas there, 1, 2, and formula 3. You're supposed to have that in an index card. So let's see the last exercise. Should I use formula 1? Should I use formula 2? Should I use formula 3? Or should I use FOIL? What should I use in there? What should I use in there? What formula should I use? Come on, what formula should I use in there? 1, formula 2,
Formula 1.
formula 1. Okay, let's observe. Let's really pay attention to this. I'm going to rewrite that. As you can see, you got 4y and you got 4y. This is positive. This is positive. You got 6 and 6. This is positive, but this is negative. So what should I do? In this case, what I should do is to rewrite my exercise. So I got 4y plus 6, and I'm going to rewrite it in order for me to have the 4y in the first spot in the second parenthesis. So you see, it is positive. So I actually don't need to place the positive sign. It's invisible now. And then I got the negative 6, which I do need to place the sign, okay? And now we got 4y plus 6 times 4y minus 6. They are exactly the same monomials, but one is adding and one is subtracting. So what formula should I use? Or should I use FOIL?
Formula 3.
Formula 3, very good. So let's identify A and B. What is A?
4y.
4y, and it doesn't matter from what parenthesis you identify it. What is B?
6.
6. And also, it doesn't matter from what parenthesis you identify it. And I'm going to use the formula that I have been using because we said it is formula 3. And we go ahead and substitute. So instead of A, 4y. And that goes to the square. Minus, instead of B, 6. And that also goes to the square. Now I solve that using a what?
Power to the power.
Power of a power. Very good. So I'm going to multiply this with the power of a power. And now I have 4 to the square. How much is 4 to the square?
16.
And how much is y to the square?
Y to the second power.
Exactly. Minus. How much is 6 to the square?
12. 36.
36, because it is not 12, because it's not 6 times 2. It is 6 multiplied twice. So it is 36. And that is the final answer for this exercise. So what are we missing? Just to place the topic name. But before, is there any question whatsoever about the topic? No? We got it? Everything is clear? Yep. Okay. It's an easy formula, right? So we saw 3 different formulas, perfect squares and difference of squares of this specific scenarios. So I'm going to give you a little hint of what we are calling the topic. It's called multiplying. Multiplying what?
Square.
No, it's not multiplying squares, but kind of.
Perfect square.
But what is that perfect square? What is that difference of squares? They are called what? Special? I gave you a name today. Special? Special cases. All of these 3 formulas are called special cases. We have some more formulas that are special cases. These are for the squares. We have also special cases for cubes. If this was a 3, for example, we also have a special formula for that. But we're just going to get to see the special cases for the squares. Any question? No? Okie dokie then. This is the topic for today.